So this is my text-based battleship game program for my midterm project. And I'll start first by showing off how it runs. It'll give us 3 options: 1 for new game, 2 for load game, 3 for exit. So we'll choose 1. Start a new game. It'll ask the player to place the ships, starting with the carrier. That's has a size of 5. We can place the coordinates through putting a column, row and column, and then the direction should be horizontal or vertical. So put 0, 0 horizontal. Then I'll update the board and display S for ship, and its placement. O is the water, and then it'll do that for each ship. So we have 5 ships in total. Then I'll ask for player 2 to place their ships. And then it'll give us the options whether we want to attack or save the game. So start by attacking. Place the coordinates 0, 0. And it'll show miss. And then I'll go to player 2's turn. And then I'll go back and forth until all the ships are destroyed. It'll show an X if one is hit. And once all the ships are destroyed, it'll show who's won. So, and then we'll show the save game later. So for the CMake lists text, we have the header files for the declarations, source file for implementations, handles the building of the project. We have our main CPP, which handles the main menu and the logic. So we have a continuous loop to display the menu options: new game, load game, exit. And for a new game, it displays the menu text, reads the user's choice and with the input, and then branches off that. So for a new game, which would be 1, it creates a game instance and calls its start game method to begin. For 2, for loading, it would ask for a file name, create the game, load the state from the file, and then start the game. And if exit is chosen, which is choice 3, it'll break out of the loop, and anything else would show an invalid choice. So show that really quick. 2 would ask for that file name for the save file, which we'll show later on, and then 3 is for exit. So for my ship header file, we have our attributes and methods, and then the implementations for the CPP. And so we start with our ship class, which is represents the individual ship, and its properties and behaviors. So it has attributes like string for the name, integer for size, and the coordinates, vectors, vector of pairs to store the coordinates, with row and column positions, an integer for hit points, and that'll equal to the size to the track damage. And the methods include a constructor that takes a name and size to set everything up initially. And we have a place ship method that takes a vector of the coordinates and assigns them to the ship after it validates. We have this sunk method, which checks if the hit points are 0 or less and returns true. If the ship is sunk, receive hit, which decreases the hit points by 1 if they're above 0, so it doesn't go into the negatives. So if we show this code, When the game asks for the ship placement, like the carrier, creates a ship object with the name carrier in size 5, and after calculating and validating the positions, it calls place ship to store those coordinates, and later during the attacks, receive hit gets called on hits and is sunk, checks if it's done. So you can see that it places it across the columns 0 through 4 and the S on the board. And that's because of the class managing the ship state. So we have the board header file. So, and then the CPP to implement. So this handles the game grid and the collection of ships for the players, and has a 2D vector in the board class, 2D vector of characters for the grid, size 10 by 10, where O means empty water. And the S is the ship part, X is a hit, and M is a miss. And there's also a vector to hold all the ship objects on that board. So method starts with the constructor that initializes the grid full of zeros. Place ship takes a ship reference, starting row, column, and direction. It calculates the positions based on horizontal and vertical check, and checks if they're within bounds and doesn't overlap any ships. It marks S on the ship on the grid if it's valid, and assigns the coordinates of the ship and adds the ship to the list, and returns true for success or false for otherwise. For receive attack, it takes the row and column and checks if it's out of bounds, and if not, it sees if it's hitting an S, and if it's yes, it changes it to an X, and it finds the matching ship by looping through the ships and their coordinates, and calls on receive hit, and it returns a pair indicating if it was hit and if the ship sank. And if it's O, it marks M for miss. For the display board, it displays the grids with the row and column headers, and all sunk loops through the ships and returns true if everything was sunk. So let's do this. So this shows up during the placement. The validation and place ship prevents any bad inputs and loops until it's good, and it updates the board. And during the turns, receive attack processes the input, updates the grid, and gives the feedback, like hit or miss if you've sunk it, hit or sunk. So let's do this. Miss. Hit. Marked with an X. And when all the parts are hit, it'll detect sync with the all sunk for the win condition. So let's try to do the smaller ship right here. Just 4-0. And we sunk a ship. And for the game header file, we have the CPP for the implementations. So this is used, the game class is used to orchestrate everything and manages the two boards and the flow. It has attributes for player 1 board, player 2 board as board objects, and an integer for current player to track whose turn it is, starting at 1. Public methods include a constructor that sets the current player to 1. So to start game, we'll check if the boards are empty for a new game. If yes, it prompts and calls play ships for each player. Then it enters a main loop. It references the current player's board and the opponent's and displays the turn message. And shows on board with the shows the player's board with the ships visible and the opponent's hidden. And displays a menu for attack or save. And if save, it asks for the file name and calls the save game without switching turns. And for attack, it gets the row and the column input, calls receive attack on the other person's board, displays hit or miss based on the result, notifies if it's sunk, and checks if all the opponent's ships are sunk to declare the winner. And then it switches to the other player if there's no winner. Switch player just goes toggles between 1 and 2, player 1 and 2. Save game opens an output file stream, and it writes the current player, then saves each board state, and load game does the reverse with an input stream, reading the current player and loading the boards. For the private methods, play ships takes a board and a player number, defines a list of ship types and sizes, like the carrier 5, size 5, down to the destroyer, size 2. And for each, it creates a ship, loops for the row, column, and direction, and then calls play ship on the board until it's valid, and then displays the updated board. Save board writes the grid row by row with spaces, then the number of ships, and for each ship its name, size, hit points, uh, coordinate number, and coordinates. Load board resets the grid to O's, reads back the grids, and reads the ship count. And for each, it reads the details, creates a new ship, sets its hit points and coordinates, and adds it to the board. So, in a new game, start game detects the enemy ships. So, let's save the game. Two, one. So, in a new game, the start game will detect empty ships, and it'll run play ships, showing the prompts and validating the inputs. And during the turns, the displays use the board's method with true or false for the ships, and saving midway writes the state, and loading resumes with the same turn and boards intact. So we'll load it. So loading, we'll read it through the file input output. It's the same one, the smaller ship being hit. And yeah, that's the program.